Hello everyone, welcome to PCCL Physics Chemistry. In this presentation, even if there is material, we are not going to measure or calculate anything. You will tell me, but then it doesn't make sense. Yet yes. We are going to talk about the direction of the magnetic field. You will learn to predict the direction of the magnetic field by knowing the direction of rotation of the current in the coil. Here is the coil. Here is also a magnetic needle, mobile. A voltage generator, a protective resistor. I apply a voltage to the terminals of this assembly to generate a current. I can turn up the tension. You can see that the magnetic needle is oriented differently. Without current, it turns towards the terrestrial north. With current, it is placed on the axis of the coil. A current is installed, which turns since it is a winding of turns. A magnetic field appeared. Its intensity depends on the voltage and therefore on the intensity of the current. Its direction depends on the direction of rotation of the current. Here we will say that the vector B is oriented to the left. Its direction is given by the needle since its south pole shows us the north face of the coil. The magnetic field leaves by the north face as it enters by the south face. I disconnect or reverse the connections. Oh, have you seen? When I open the circuit, a spark appears between the contacts. I start again. There, the needle is only subjected to the Earth's magnetic field. If I reverse the connections, the compass needle is now in the other direction. The induced magnetic field is to the right. You see that the current is now flowing in the other direction. Can the direction of winding of the turns play a role? So I will go back to the previous situation. Red on red. The magnetic field is to the left. But if I use a coil whose turns are not wound in the same way, connecting it in the same way, you see that the current will have another direction. And the magnetic field is to the right. This means that the direction of winding of the turns is important. What matters is the direction of rotation of the current. And there are mnemonic ways to remember that. I like the right-hand rule. I find it very simple. Fingers. There are 4. It reminds the whorls. They show the direction of rotation of the current. Therefore, the direction of the magnetic field is given by the thumb of this right hand. It's noted here. You can use another mnemonic. If the current turns in this direction, we arrive at the letter N, which is the first letter of the word north. We saw in the video on the bar magnet that the magnetic field comes out from the north face. When I look at a face where the current is turning clockwise, I see a south face. This is the side of the coil where the magnetic field enters. That's it for this video. Thank you.